Hey everybody, Caleb here. Welcome. In this episode, we're going to cover the absolute basics of Java, and we're going to try to do it rather quickly. So, if you don't want to go watch an 80-hour series, this is the video for you. PVS Studio is a tool that detects errors and potential vulnerabilities in your source code, working with C, C++, C#, Java, so you can get plugins for Maven, Gradle, and IntelliJ. Whether you're on Windows, Linux, or Mac OS, you can get started. I'll leave a link for you guys in the description, one to an article talking about some of the most common errors found, as well as some comparisons to other popular tools, and a link to download the software. You can use the promo code POUNDCALEB, and that'll get you a 30-day free trial, so check that out. So whether you're a beginner getting started or you have a large Java project, this software can help you find bugs before production and save you a lot of time, energy, and money. So go give it a try, link in the description. So what we're going to do is we're going to create a new Java project and start completely from scratch. I'm assuming maybe you get to this point and you don't even know where to go from here. So we're going to hit create a Java project. Now I'm using Eclipse, that's the IDE of choice in this case, but you can use other IDEs. The main important stuff here is the actual code. So what we're going to do is we're going to create a Java project and we'll just call it Learning Java. And you can keep pretty much everything else the same and hit finish. Now this module info thing, you can just click don't create. Modules are just another way of organizing your code, and we're not going to need those right now. Now when you create this project, it's going to show up over here on the left. It's pretty tiny, and in here you have this system library with a bunch of junk, and this is the stuff available to us to use in our code. We're going to minimize that. And then we also have this folder called src, which is source. And this is where we're going to put our source code, our files. So what we're going to do is we're going to right click this and hit new. And then we're just going to go with a new class. And we're just going to call it the same as the project. So we're going to call it Learning Java. And when you do this, you have the option to select public static void main string args. And I would recommend you check this. That's just going to generate some default code, and this is going to define where your program should start. So steps are create a project, then create a class, and put this public static void main inside of it. Hit finish, and then the code pops up, and you can zoom in just a little bit. I'm holding command and then pressing plus. On Windows is probably control. And this is the code we're going to work with, and then you can kind of minimize or X out of some of the stuff that you don't need by hitting the X or the minimization button, and that'll go off to the side. If you need it again, you can just hit it there. Awesome. And we're going to keep, actually no, I'm just going to minimize everything. So we're just going to focus purely on the code here, and we're just going to try to break this stuff down and get a basic application going. So what is going on here? Well, you can see we have this class, and in Java, everything is broken up into classes. So you're going to become very familiar with this keyword, and don't let it frighten you if you're new. Basically, this is the start of something known as object-oriented programming, and it can be complex, but once you do it enough times, it's going to be second nature. So in Java, everything is broken up into classes, and classes have names. In this case, this class is called Learning Java, which that's the name we gave it. So you could also create other classes with different names the same way. Now in here, this is an example of a method, and methods do things. So this is where we're going to put our code that's going to do stuff. Now we're probably going to create a bunch of methods in our Java career, just like we're going to create a bunch of classes. So don't ignore methods and try to understand everything here. Now with this method, there's a bunch of different keywords and syntax going on here. You don't necessarily have to understand everything here, although I'm going to try to explain the basics just so we can get the full crash course experience. So we have a method, and its name is main. So this is called the identifier. It's just a fancy word for saying what the name of the method is, and the identifier is main. So if I were to comment some stuff, I would say main, and this is the identifier, just so you guys can see everything spelled out. The next thing is we have this public here. This is an example of an access modifier, and sorry, I got the arrows wrong there. So public is an example of an access modifier. Now static, this is I don't really know what to categorize it as, but this is in contrast to an instance method, which we're going to get into later. Basically, when you see something with the keyword static, you're able to call this method directly on the class. And we'll get into all that junk later. And then void, this is an example of a return type specifically. So void means nothing. In other words, this method doesn't return a value. It doesn't give an output saying, hey, it worked, or give back a certain value by calculating some number. It doesn't give anything in return. So in other words, this method main, it's going to run, it's going to do its thing, and then it's going to stop running, and the program is complete. It's not going to give anything once it's done. So last thing in here, we have this string args. This is an example of a parameter. So the string args is an example of a parameter. And basically, a parameter is going to take information as input. So this is just a fancy word for input. So now that you got all these vocabulary words out on the screen, we can kind of start memorizing these things so we understand how things work. So with a Java application, the main method is special because when you run a Java application, it's going to look for the main method and start executing whatever code is inside of it. So we'll start writing out code, but anytime you see these 2 forward slashes, it's just a comment, meaning I can write whatever I want and it doesn't affect the program. So the next thing on here is what code do we actually put inside of this method? And if you don't understand all of this stuff, that's okay, because as you start building things and doing more code and you get some more experience, all this stuff's going to make sense. So don't feel like you have to understand it up front. I just wanted to throw that out there because I see a lot of videos on Java where they basically ignore all of the pieces surrounding your code. And as a result, it's kind of a stumbling block when it comes to progressing in their Java development. So for you guys already know all these keywords. Now you can study them and you'll see them again in the future. So the very first thing is you probably want to do a hello world. So what you can do is if you want to do a shortcut here, you can say sysout and then hold control and press space. And that's going to pop out into the system.out.println. If that shortcut doesn't work, or you're using a different IDE, or you're on a different operating system, then what you can do is you can just type it out manually just by following the same thing. So system.out.println, and then putting parentheses and a semicolon. And everything has to be exactly like that. You can't change the capitalization. You can't change the dots to a comma or anything like that. It has to be exactly like this. And then inside of these parentheses, you're going to put double quotes, opening and closing. Now, this is the part that can change. So you can put anything you want in here, and that's fine. So you can put your favorite food, you can put your name, you can just put hello world, whatever you want. It's very common for people to just put hello world because it's kind of like the absolute most basic application they can write. But we're just going to say this can change. And then to run this thing, all you got to do is find the little play button, hit that, and it's going to pop up with the output, which says this can change. So there you go. You just wrote your first Java program, but it's nothing too crazy. It doesn't do anything fancy. So we're going to start learning some of the other stuff that makes Java a little bit more interactive. So for example, instead of just doing output, this is an example of output. What if we wanted to do some input? So we wanted to get input from the user. And we do this to make our applications more dynamic. So we can ask the user questions, we can change the response based on what they said, and so forth. This is the basis of complex applications. So I'm going to be teaching you guys how to do input. And again, if you don't understand all this, that's fine. I'm just trying to give you a little taste of what's possible. So type this out exactly as is. Scanner is equal to new scanner. And you'll notice that this one has a capital S, this one has a lowercase s, and this one has a capital S. And then what you want to do is you can hover over this. You can see there's like this red line underneath of it. Hover over it, and you'll see all these different suggestions. Basically, this scanner class we're trying to use, it's not recognized, and it's like, what do I do with this? So when you hover over it, it's giving you some suggestions to import the code needed to use this scanner class. So you can see a bunch of different options on here. The one we're interested in is the one that says java.util. And when you hit that suggestion, it's going to pop up here with import java.util.scanner. Now, if you're in a different text editor and that suggestion doesn't pop up, that's fine. You can just type it out up here and that works just the same. Now you can see we're not getting a red line here. We're getting a red line here, but that's for a different reason. I'll talk about that in just a second. So what's going on here? We have this class. This is another example of a class similar to how we defined our own class here. There are classes available to us in Java, and one of those is scanner. This word here, the lowercase s, this is the identifier. It's the name we gave this object. So when we create an instance of a class, it's called an object. And the way we create an instance of a class is by saying new, followed by whatever class name it is. So just memorize the syntax. It's a little wonky, but you'll get used to it. Now, the reason this is red is because it actually requires data passed in as an input. So what we're going to pass in here is we're going to pass in system.in. And that's going to allow us to get input from the console. Next up, what we do is we say scanner.next line, and it's going to look like that. And that's going to scan a line of user input, and we're going to store that in a variable called input. So that is what the code is going to look like. And then down here for the output, we can put in this variable input. So we'll copy that and paste it here. So take a look at this, make sure you understand everything. Basically, we're making it so we can read from the console. We're reading from the console and storing it in a variable called input, and this variable is of type string. We're going to talk about types next, so don't worry about all that right now. Just type this out as is, and then whatever we typed in, we're going to output that to the screen by passing it to the system.out.print line. So let's run this and see what happens. Go. When you hit this play button, it's not popping up with the console, and that's fine. Just go over to wherever you minimized it and hit restore, and that'll bring the console here for us to work with. Now, if that's not working and you can't find it, what you can do is you can go up to help and you can type in console, and it'll tell you how to find where to activate that. So you go into window, and then you go into show view, and then console. So that is how you get this popped up at the bottom. Now it's not showing up anything here because it's actually waiting for us to type something in. So we can say hello, and when we press enter, we get that same exact output. That's because it's just taking that input and just putting it right back into the output. So what we can do is we can go an extra layer and we can actually ask them a question. So for example, we can say, what is your name? And now when we run this thing, we get a prompt up front to which we can say whatever your name is. And when you press enter, you're going to get that value back. So that's the basics of input and output, as well as just what all this other junk is. It's a lot. So if you're brand new, then this is going to just take some practice, but as you go through these videos, it'll get a lot easier. So really don't worry about it. And if you have experience and a lot of this is just pretty easy, then great. It's always good to focus on the basics and get a little bit more review. Now, one thing you'll notice in our code is that we're creating variables. So for example, this input is an example of a variable. Scanner is a variable. And the thing on the left here, this is known as the type of the variable. Java is said to be statically typed, and what this means is every single variable has to have a data type. This is different than other languages. If you've ever used JavaScript, for example, in that situation, you don't have to define the type of the variable up front. It's dynamic and you don't have to worry about it. But in Java, input will always be a string data, and in that situation, it's something like Caleb Curry, and you can define a string in your code using double quotes like so. So that's the basics. Hopefully that was helpful. Now what we're going to do is we're going to build upon this by learning about the types inside of Java, and yeah, it's going to be pretty sweet, so stay tuned for the next episode. Hey, welcome back everybody to episode 2. Looks like you're doing pretty good because I'm pretty sure most people end up quitting learning code after about one episode. So if you made it to episode 2, you're on the right track, and it just gets better and better from here. So I'm really excited for this video because we're going to be learning something in a little bit more depth. So based off of the code we used in the last episode, we have a scanner, we have this input, and these are examples of variables. And variables can store some value. So for example, whatever we type into the scanner, such as Caleb, in this situation, that value is stored in this variable input. Variables inside of Java have a specific type, and they will always be that type. So in the situation of input, it's of type string. And what is a string, you might ask? A string is just a sequence of characters, often denoted by double quotes. And in this situation, Caleb is a string. We type that in, and it's stored in this variable input. But string is not the only type available to us. For example, scanner is also a type. It's a little bit more complex, but it is a type. Now, there's kind of like these building block types that are used to build larger types. And these building block types, you can think of them as little Legos. You take these different Legos and you piece them together, and you can start to build complex things like cars, or, well, not like actual cars you drive, but little, that should have been implied, but you can make little things that you can then play with. And the same thing works with Java or any other programming language. You learn these Lego pieces, and you can start piecing them together to make more complex things. So for example, this scanner type is actually just built using a lot of these more smaller types. Now these smaller types are often called primitive types. You can think of primitive as simple, not very advanced, and you can also think of it as primitive because they're just built into the language, and this is kind of the actual definition of primitive. They are the variables that are included in the language and can be used in any of your applications. So let's just take a look at some of the available types that we can use. And a good resource for this is the documentation. So take a look. Now don't be overwhelmed by all these different types here, but we have byte, we have short, we have int, long, float, double, boolean, and char. So these are the equivalent of Lego pieces that we can use for the rest of our applications. Now, the real ones you need to know from this list are int, double, boolean, and char. You'll probably run into the other ones eventually, but if you're brand new learning the types, these are the ones you want to focus on. So once you learn integer, double, boolean, and char, picking up the other ones, no problem. So let's go through an example of using one of these types. Let's go back to our code here, and let's just clear out what we got. And what we're going to do is we're just going to print some numbers. So you can print the value 5, and just so you guys know, anytime you type a value out in your code, this is known one of two words. One, it's known as a literal. So you're literally typing just the value. You're not getting it from user input or from a database or anything like that. It's in your code. It's hard-coded in your source. The other word you might hear is a constant. So when you hear the word constant, it can sometimes refer to a value typed in your code, such as this value 5 or this string hey or whatever it might be. So when we type in a 5, we can run this thing and we get, yes, save, and then we get this value 5 in the output. So we are using a literal 5 and we're outputting it. But we can also create variables of this type. So for example, we can say int, give it some identifier, and assign it the value 5. Then we can use this variable instead of the value 5. And we're going to get the same exact output. And you might be wondering, why would you want to use a variable if we get the same exact output? Well, it allows us to just make more complex applications. And when I say complex, I mean more useful, larger applications, not necessarily more complicated. So for example, let's say we wanted to output this value 3 times. So we had 3 system outs and we printed the same value 3 times. And we run this, we get 5, 5, 5. And if we wanted to change all 3 instances, we would only have to change it in one place. So we can change it to a 6, and when we run this, we now get 6, 6, 6, which I swear I did not mean to do that. Let's go with a different number here. We'll go with 7, just a little bit better there. All right, so in this situation, we are saving ourselves because we don't have to go through and change the value in 3 different places. If we weren't using this variable, we'd probably have it typed out like so. And then if you wanted to go change it, well, then you would have to go and update every single instance. And you might forget one, or you might have a typo and accidentally put a 0, and you might not notice it, and this introduces bugs. Bugs are just anything in our software that makes it not work the way we want it to. So bugs don't always get caught in the compilation. So for example, if I mistype something, it's not even going to let us run this application because it's going to say there's errors, and it's not going to work. But sometimes we get logical bugs. In that situation, the code compiles and it runs, but we might not get the output we expected because we might have expected 333, but instead we get 3330. So you really got to watch out, and anytime we can reduce or eliminate repetitive code, we want to do that. So instead of putting a 3 here, we can just use a variable and then set the value of the variable to 3. All right, so enough about variables. I'm kind of going on a tangent here. The main thing here I wanted to talk about is types. So this is an example of an integer type, but you can also use a double. And the difference between an int and a double is that a double allows for things after a decimal point, such as 3.5. And you can output this the same exact way. It's output x, and we get 3.5. You can also use doubles for whole numbers. So for example, you can have 3.0, and we can run this, and we get 3.0. You can also store an integer in a double. So when we put a 3 here, this is said to be promoted to a double. So we run this, we still get the value 3.0, even though we didn't type out that 0.0, the value is converted or casted to a double. And then when we output this, we get the double representation of that number. It doesn't necessarily work the other way around though. So for example, if we created an integer y and we tried to assign it 3.0, we're going to get an error. And look what it says. Type mismatch. Cannot convert from double to int. The reason it can't go back the other way is because Java is not going to let us do any automatic conversions that could result in some loss of data. Imagine if we tried to store 3.5 in here and it would let us. Well, in that situation, it's going to crop off that 0.5 and just give us the value 3. And that data is then lost. Some languages might let you do this, but in Java, it's not going to let you do this, and it's going to be a compilation error, meaning we got a red line and is not going to let us compile. If you really want to force it, you can add a cast to int, which it actually recommends here, and when you do that, you're just going to put this in parentheses beforehand, and now when we output this, we'll output the value y, it's just going to crop off that 0.5, and we're going to get the value 3. The other data type you should know is char, which is short for character, and this is what that looks like. We're going to say char, we can just call it C, for example, and give it some value. We'll just give it the value y. So a char has single quotes instead of double quotes, right here and right here, but outputting it and using it works pretty much the same way. You can run this, and we get the value y. It can be a little bit confusing because we're using a character as the identifier, so maybe we would change that. Just give it some other name, doesn't really matter. And then the last one is Boolean. So for example, we can go in here and we'll just call it B. We'll change the type to Boolean, and this has one of 2 values. It can be true, notice there's no quotes, it's a keyword, or it can be false, which is also a keyword. And in this situation, when we output it, it's just going to output that word. So when we run this, it's going to say false. And if you keep getting this pop-up, by the way, where it's asking you to save, if you forget to save, you can just check always save resources before launching, and you don't have to worry about that popping up. and you don't have to worry about saving it every 2 seconds. All right, so that is Boolean, and that's going to be used a lot for logic throughout our program, so we can basically evaluate different expressions to see if they're true or false. So here's a simple example of this. What if we wanted to output sys out, and what we did was say 5 plus 5, 2 equal signs, 10. And this might look a little weird if you're not used to logic inside of programming, but basically this is going to compare the values. Is 5 plus 5 equal to the value 10? And when we run this, you can see we get true. If we put something that's not true, such as a 6, in this situation we're going to get the value false. And later on we'll do similar expressions like this to branch in our code and allow us to do different things based on different inputs or different values. And that's how things work. So for example, when you go to a website, you can log in and it'll basically do some condition like, hey, if the password is correct, let the person in. Otherwise, kick them out, tell them to go away, and so forth. So that is the basis for pretty much all of coding. So it's pretty cool that we can do it pretty simply here just inside of a print line just to see what the output is. But later on, we'll get into if statements and loops and all that good stuff. Now there's one other type you should know about, and that is the string type. Now, taking a look at the documentation, you can see that this list here are known as the primitive data types, but you often learn about strings with these primitive data types, even though they're not technically primitive data types. So here we can see strings, and it shows how to create one. This actually comes from the java.lang.string class, and it's just not technically a primitive data type, but considering the special support given to it by the language, you'll probably tend to think of it as such. In other words, behind the scenes, string is not a primitive data type, it's a complex type, but you can use it as a primitive type. But there's a couple gotchas that you need to be aware of. So for example, let's go back to our code, and we're going to create a string. We'll just do a string literal, hello, and we'll see if this is equal to hello. And when we run this, we'll probably get true. And this is not always the case. And in fact, you don't want to use these double equals with strings. Instead, you want to do dot equals. And this is a particular method that we can use. So what we do is we take this value, cut it, and paste it in here. So this is the proper way to do things. And this is always going to compare values. When you use the double equals, it's going to compare memory locations, which is not the same thing. Whenever you're comparing strings, you always want to do the dot equals method because using the double equals is not guaranteed to work. And if you want to know more about this, you can look up a concept known as string interning if you really want the juicy details. But in general, you do not want to do this. So those are the warnings for strings, and now you understand that it's not technically a primitive type, but it's used very similarly. It's one of the building blocks to make them more complex types. Now another category of types is collections. An example of a collection would be an array or anything that can store multiple pieces of data, and we're going to get into those later on in this little series. So stay tuned and check out the next video because we're going to get into some more juicy details. Specifically, we're going to start talking about control flow. So earlier, I gave the example of comparing two values, such as 5 plus 5 being equal to 10. What if we want to branch based on some comparison if it's true or false? That's what we're going to be talking about in the next episode. So stay tuned and don't quit.